Hello, hello, hello. Welcome. This is Twitch Stream Thursdays. I'm Mofi.
I'm Nick.
So this week, Nick, we're going to talk about some more Docker stuff. So you remember 2 weeks ago we talked about some basic Docker things. You remember most of it?
I remember there was like one command that we could run, and it ran like three other commands, but I don't remember what any of those four commands were.
So you should first
Like
start.
Docker run.
Yeah. So Docker run did a Docker pull. It did
Okay. Cool.
Docker pull, start, and attach.
Pull run. No.
Pull, start,
attach. Okay.
So basically, or exec, whatever command you're depending on what you're putting in the end.
Okay.
So it might even do attach and exec if you do -it. -it would be interactive TTY. So if you want to attach a terminal shell to the Docker image. Again, we're going to go over this many more times throughout our sessions. But this week I wanted to talk a little bit more about what you can do in terms of like using someone else's image is nice because someone else did all the work. Just do the run command and it just does all the things for you. But what would be more fun is to be able to build your very own images that you can use anywhere you need to. And I think that's most useful because your application needs are completely like your own. It can't really expect someone else to have every single possible combination of the application that you will have. So on that note, what I have actually two Docker environments depending on what our users are doing. I have Docker installed and running on a Mac environment. I have also Docker installed and running on a virtual machine in Ubuntu. So this is the Ubuntu environment here. So I have Docker, if I do Docker version, you'll see I have Docker version this, Docker info. If I do, you'll see that like all the things that are installed here. And Docker being like a higher level primitive in terms of like container runtime, the versions and all the other things that's inside Docker, doesn't matter which like OS you're running it on, it'll be pretty much similar. So if I were to go back here and do a Docker info on my Mac, you would see most of the things other than the root level things like which folder it's running on or like which OS it's running on. Most of the things other than that would pretty much be the same. Like how many containers I have running, what version of Docker I'm running. So apparently, like I installed this morning, and my Docker running on my Mac is like a couple of weeks old. So the sub version is a little bit different, but it's still Docker 18.09. The file system and other things, it will be pretty much similar depending on what Docker had access to. So we have both of this running, but we want to do a couple of things. So I know for your application you did create an image. How did you find that experience of creating a Docker image?
So I think I kind of just Googled stuff.
Right.
And then kind of kept sort of tweaking it to get it to something that I needed. And I went to some of your meetups, so that information kind of helps me.
Okay.
But I'm still a little pretty much newbie to.
Right. So Docker image it is the kind of blueprint of what a Docker container is going to be, and Docker image. You can build Docker image in a couple different ways, right? If you want to build it. If you want to get it from a registry, we used Docker Hub in previous lecture. We're going to do that again today, like a couple of things. So Docker Hub has a bunch of official Docker images. That would be what we call base images for other images you want to build. For example, you have a bunch of Ubuntu releases. Let's look at a couple of this. Okay, where's my Chrome? Okay, here we go. Docker Hub. I'm just going to my user, but what I want to show you, let's say I look for Ubuntu. Here, you'll see Ubuntu it's a Docker official image. So any Docker image that has a Docker official image tag, you know that Docker Hub itself is checking for like issues with this particular image. Another thing you're going to see with the official images, when you try to pull those images, you don't really have any user tag on them. You just call the image by its name, and Docker Hub knows what image you're talking about. But if you look at the tags here in this Docker Ubuntu, you will see there is a lot of tags, right? There is like 13 page, each page having like about 30 tags worth of tag. And so each of these image has, some of them are like super similar, but the reason they have so many different versions of any image, they have different versions. So they have minimal images, more complete images. So they have 18, they have 19, they have newer versions, older versions, really small packages like 28 megabyte size. Also, they have images that are like close to a gigabyte in size. right? So you have all these different versions of images, and you can use any of that as your base image and start from there. And depending on, so the reason some of them are bigger and some of them are smaller, the smaller ones has less things in it. Basically, it will not have too many tools installed in it. So you can just like start from a very minimal image. But you can also look for images that are by default small. Um, for example, there is an image called Scratch. So if you have some sort of binary that you want to install things on top of, you can use Scratch. And Scratch is a super small, super minimal image size. Like most of the Scratch images you're going to see here are going to be in the size, like range of 20 megabytes. And Scratch doesn't have literally any Linux tools installed in it. So if you have a binary like a program written in Go, C++, Rust, you just copy the binary into Scratch, and Scratch can just run it. So basically, again, we can find base images. We're going to look at base images in a second. But a couple of other things we want to quickly showcase about building images. So I created myself a handy dandy, basically a cheat sheet so that I don't mess up running this command. But what I'm doing here, I'm gonna let's quickly see what containers I have running. Oh, sorry. And so I had like OpenShift thing running here. I'm gonna actually get rid of that. I'm gonna get rid of all the images that was running. Ooh, that was a big image. So right now, if I look at it, I have basically zero things, nothing running. So what I'm going to do, I'm going to run this Alpine image. Alpine is also another base image, official Docker image. And I'm going to run a shell. I'm going to attach a shell to it. I'm going to interactively access this. So this run is going to then go ahead, going to do what? It's going to do a pull.
Yeah, a pull,
start
and
attach and exec, right? I'm execing some command in the end, right?
Okay.
So I'm gonna, once I do this, you're gonna see a bunch of things happen, and I am inside a shell right now. So Alpine's package manager is APK, so I can do a APK.
Quick question: how do you choose, like, if you use Alpine or like?
So yeah, that's a really good question. But the point is, you want to limit your attack vector. Right? Like if someone, or also just like get the most minimal thing that works. So I personally, every time, because I do a lot of things in Go, I almost always start with the Scratch image because Go is a compiled language. I have a binary, so I have no reason to have like a whole Ubuntu suite of things installed in it. If you're doing something like Node, Node needs a lot of other things installed on the system during the runtime. So you might start from the Node base image. But let's say you use the Node base image. If you're, let's say, for your application, I know you use this React application, you have some sort of build done right in the end. That build only needs to be served. You don't necessarily need the Node runtime to be able to serve that image, serve those files. At that point, you can use anything like Alpine or anything just that has a like server.
Okay.
Right. So basically, if it's not a matter of like if someone will like hack into your container, it's a matter of when they do. When they do, you want to give them the least amount of things to play with.
Gotcha.
Right? If you give someone Ubuntu, they will have access to SSH. They will have access to ping. They'll be able to like figure out what are the other. They will have access to IP utils. Then they'll be able to access what the other things that this particular container is talking to. Then then they will find the IP address of other things that's running on the same network. But if you don't have IP utils in the system, it will be a lot more difficult for them to do those things. Right? Okay. Yeah. We're going to talk about like a root access in a second as well.
Is there like a nice like table or something that I can look at that'll like tell me what everything has?
Well, we're going to actually do...
Is it like you just start from scratch and then like, oh, you don't have this command, then Google like which image has this command? Right.
So right now, the Alpine image that we downloaded, right? We're going to actually quickly take a look at... We're going to install IP utils. It doesn't have IP utils right now. We're going to install IP utils. So apk update and apk install IP utils. And it's going to go ahead and download a bunch of things. Ooh, hold on. I messed up the command. Let me see what it's supposed to be the command. Apk add. Oh boy. So in Alpine, it's apk add, not install. What's your favorite Linux distro other than macOS? That the one you use?
I have no idea.
um, yeah, like I actually used Ubuntu pretty rigorously for a while. So we just did this, right? We just installed the IP utils in this, bunch of things installed, and now I can like exit out of this. Once you exit out of this, if you do a Docker PS, you will see this is no longer running because again, there's no long running process. I can see Docker PS shows you that it was created and exited 6 seconds ago. So what I want to do is like do a diff on this. So when you do a container diff, it looks at the base image that the container is running off of and see what changed on it. So Docker diff container diff sample. So when I do this, you're gonna see a bunch of this text printing out. And in front of each text, there is a C or an A or a C or an A, right? Like you see, there's these two letters. So
Right.
what do you think this letter C represent here,
Uh,
or the A? All right.
actually, I don't have no idea.
So the C means it
Don't
got
even know
it.
what time.
C means it changed, and A means this new thing got added. For example, the trace route 6 was not built into Alpine. Once we installed IPutils, that got added to the system,
Oh, okay.
right? You have a bunch of things that got changed. For example, ping was already in Alpine. That's what when I typed in ping, it showed me ping was there. But we basically changed it by installing IPutils. Ping got like either upgraded or updated. So a bunch of things got updated and a bunch of things got added, like libcap and all these other things, setcap. All these things got like thing. So let's say this is the image. I changed that image to make an Alpine base image that I can use now because for some reason I needed those IP utils and I don't want to always start from Alpine then install it manually myself. So like right now I have an container that has all these things installed inside Alpine. What I can do now is then take this and store this as a new image called, let's say, my Alpine, right? So what I can do, so you can just do a commit, and what commit does takes a container, converts that into an image.
Okay.
So looks at the running current state of the container and converts that into like a blueprint of an image.
Okay.
So once I do this, it will create a SHA of like a like certificate that's saying that this is this image. It'll create a tag for it. And if I do Docker images, now you'll see I have this new image called My Alpine. And this is a little bit bigger because again, this has this IPutils things already installed to this particular image. Now, if I start from this image as my base image now, I can then like already have access to IPutils without having to install it. So this is definitely one way to create images. But the main issue with this particular way of building this image is that every time like you keep building your image this way, and this probably works for just one person teams, or like if you're just testing things out. But if you want to truly build a production ready application, once you leave the company, or like if once you move to a different project, no one has any idea what magic you did to get to this particular image because
Right.
there is no written document for it.
Right.
So the other way of doing things, and if you've done any Kubernetes, you'd also see like you could manually change the Kubernetes deployment as all you want, but that's not recommended because again, the same problem. Like once the bus factor, if you get hit by a bus tomorrow morning, no one knows what you did to get to the application to the state, and no one knows how to get to the application back to that state. If something is something breaks and you need to go back.
Right.
So Docker has a different way of doing this thing. It's called a Docker file. You built a Docker file before, so what was that
Yes.
experience like for you? Like building the Docker file itself.
Right. So like, as I said before, I kind of just, I copy and pasted stuff, and I don't remember what like base image I was using. I think probably Node.
Okay.
And I copied files from my computer into it, and yeah. that was
Okay.
about
Yeah.
it.
No. I think that's most people start at that point, and which is not a bad spot to start. But there are a few commands, and I would like to quickly show you. I'm going to just open up a new notebook, and I'm going to call it Docker. And then if everything else goes right, I would be able to connect. Okay. It's finding everything except my, hold on. It is Reflector. There you go. This is also an app that I use for connecting my devices called Reflector. I'm a big fan. Works great every time I have tried using it. It has just worked, except for this one time I was trying to. Okay, Reflector 3. What is it doing? Am I not on the same network? Open internet. And it's not connected to the internet. That is the problem. Okay. All right. So I think right now I'm connected. There we go. 1, 2, 0, 3. With that. Okay, great. So okay, so Docker, when you're trying to like build an image, Docker have few keywords that you have to remember. Number one of that is from.
Yeah.
And from is the keyword that you use for getting a base image from something else. So you'll say something like from Alpine or from Ubuntu or from Scratch.
Right. Yeah, I think I have like from Node.
Right. And there and the Docker also under the Docker have like official images. They have a bunch of language specific images for Go. They have for Node. They probably has a couple for Java and like so on and so forth. So that's number one. The other commands you have that you will use a lot is run. And run basically takes one Linux argument like a command next to it, and that is the one that runs in it. So you can say something like cd into something, or you can say something like apk add something. If you're using Alpine, you can apk add something in it. So you can do a bunch of things of this nature. And then you have two commands. Ooh, not the right color. Just trying to go for the screen. So you can do things like add and copy. And so add and copy, like for most of the use cases, does pretty much the same thing. But add is a little bit more powerful than copy. If you with add, you can actually do like a zipped file, and when you add it, it's going to unzip it for you. Also, with add, you can also add like a network file, like with some URL. It will download automatically into Docker image. So if you're not sure which one you need, it probably copy is a little bit lesser in scope, so you probably should use copy. But again, add has a little bit more power. So like if you need to get a file without downloading the file in one step, or like copying a zip file then unzipping it in the next step, you just add it and it automatically unzips as it copies.
Yeah, I think I use copy, but
right. I mean, if you know that your file is just a regular file, probably like using the list scope is the best use. But I can use add and copy. They add files to things, and then you have a couple of other commands like entry point and cmd. Entry point and cmd are kind of like similar in scope as what they do. They both take an array of things as a command, but command is the basically used for passing in the arguments for entry point, unless you pass the command itself inside command. It's a little bit confusing, it sounds, but like once you look at it, you're gonna know exactly what you're talking about. But basically, in entry point, you'll say something like entry point could be for like a node application. Entry point could be something like node, and the command will be an array of all the other things the node command needs. Like, give me an example. What would like node, like file name, right? Server.js.
Yeah.
And then probably it has some other commands like -p, -5000, something like that. So that could be the command. So Just with that, you were almost you pretty much can like create a not even all of that, but basically you need the from because you need to start somewhere. You need either entry point or command if you want to like start a process when the Docker run happens. Add or copy if you almost always want to copy something from your machine to the Docker container. So basically with that, you can pretty much do most of the Docker stuff, but there are a few other commands. Uh, Things like you have workdir. And work, I didn't change the color. Why did I erase it then? So what workdir does basically sets the context of where the run command, where the entry point of the command should run against. For example, if you do like a run a cd command, run commands doesn't kind of like continue. So once you run a cd command, the next command doesn't run from the directory you changed to, right? It just runs from the same base directory you ran every time. So even if you cd and don't end and run the next command, the next time you run again, it's gonna basically start from the like root of the directory once more.
Right.
So the change doesn't persist on run. So if you set a work directory to a directory you want to do something from, that will stay, and all your entry point and command will run against that particular. So you want to set a work directory. There are a couple more. For example, you can set a user, and you should definitely set a user. If you don't
not set a user.
Right. If you don't set any user, by default that runs as a root. And you running a Docker container as root, although it's the most easiest thing to do because if you do nothing, that's what happens as default. But it's super dangerous, and any user that has access to Docker, even though they're not root, they can easily like hack Docker a certain way to access files that are privileged for root user only. And I have like a quick short demo to showcase how that works out. So again, I'm in my Ubuntu VM because again in my Mac, my user is also the root user, so I can really showcase it as properly. But here I am just like a regular user. My name is username is Murphy, and that user don't have permission to do a lot of things. And if I go back here, I have a file here called secret.txt. If I try reading this file, I will see that I don't have permission to read this file. But basically, because I can read this file, because if you look at the permission for secret.txt, it's only under root has read and write permission, and no other user has any other permission on it. So, but let's say I don't like that happening. And also imagine I don't have access to sudo. I do have access to sudo on this particular machine, but imagine I don't have access to sudo, but I do have access to Docker, right? I can access Docker. That means, and I can create a Docker image, a Docker container with root permission. And let's just show it. You're going to see what just happens in a second. So I'm going to go into my documents and Docker, and I have this Docker file, and what this Docker file is doing, nothing magical, but it just like it starts from is the command for getting the base image,
right?
And we're getting the Debian scratch. It doesn't really matter which one you do, but this one I'm just using a Debian, and the command I'm running is a cat. It's a cat command, and it's just catting that /temp/secret.txt from the Docker image. Again, right now /temp and secret.txt means nothing. But let's just build this Docker image. Do I have an image build already? I don't. So good. Docker build, and I'm going to give it a tag. The tag is going to be root reveal because I'm going to reveal root access files. Again, sinister name, and dot is going to say look for a Docker file in this current directory. We didn't really do Docker build too much, but this is a quick example, and this is also like the first easiest example to show because the Docker file itself is just 2 lines. So if I do this, the Docker daemon is going to go ahead and download the Docker Debian because it didn't have that base image, and then download once the download finishes, it's going to just build this image. It just finished building this image, and it has 2 steps only. Downloading was step 1, and adding this command as the step 2. Next, what you want to do is Docker run this particular image. But before I run, I'm going to attach a volume. The volume I'm going to attach is going to be home secret.txt. That's the file I don't have access to as this user. And then what I can do is /tmp/secret.txt. That's the file I'm mounting on the container. And that's, if you remember, that's the file I'm trying to cat here, up here, right? Okay. And what I named it, root reveal. Yeah. Okay. Okay, so I'm running this particular Docker container. A Docker image is gonna spin up a new container, and this is gonna volume mount this. So if I run this, if everything else goes well, I can see I have actually seen this file while never changing my user.
Or your password.
Right. So again, this is a password I just randomly typed in. So if you're trying to type it in, like, please don't. It does nothing. But if you want to set this as a password, it's a pretty good password. But don't do that. It's going to be a video available online. Anyway, so the point is that if any user has Docker access in your particular machine, they have technically root access in that particular machine. So you can have all sorts of firewall for user permission, but if the user gets Docker permission, it doesn't really matter if they don't have any other permission. They basically have permission to do anything in your system. So that's the reason you should never run a Docker image as a root user. Because again, the moment you do that, basically you're letting anyone access Docker as a root user then. So this is all the things I want to do. So before I continue with the Docker image itself, let's show a couple of things here, because like we saw here, there was a step 1 and step 2. What is these things then, right? So Docker uses something called the union file system, or UFS, or union. And this is one of the I think the best technical advantage of Docker over the previous tries to create a container runtime system, because what union file system can do then is build this image on layers, and they do another thing called copy on write. This is also allows Docker to have a very minimal footprint in terms of hardware, space requirement. So what the union file system says is basically you build your image on layer on top of layer, and if the lower layer doesn't change, your image doesn't have to rebuild those parts anymore. You can just keep build on top, and keep building on top. That's why you can take a base image and modify the base image and convert that into your new base image and start building on top. And each layer you add, basically right now in the previous example, we had 2 layers because we had 2 lines on our Docker file. So every single command on your Docker file will correspond to 1 layer. So a couple of best practices, again, I'm going to sneak it in here. If you can consolidate your Docker file commands into 1 large command, you should definitely try doing that. You should also try to have files that changes more frequently on top, in terms of on the bottom, on the Docker file, because let's say if you're building a node application and you have npm install happening, before you copy your actual files, you should copy your package.json and do the node npm install on that first, because your package.json doesn't really change that often, right? But in your union file system, let's say you have this big stack, and this is the bottom, this is going all the way up to the top, and this is not the best color for this. I'm going to actually choose so I do this, and I have these stacks, and this is layer 1, 2, dot all the way to layer n. If for some reason something in layer 1 changes, and that the checksum doesn't match, Docker will have to rebuild everything on top. So the things that are changing more often, more frequently, you want to have that as higher up as possible, so that their change doesn't affect the next versions. For example, going back to the example of the npm install, let's say you start with the base image of Node, then you add the npm package.json into your Docker container, then run npm install right away. then you basically copy all the other things you need to copy. Your file that you're coding away, that will change more frequently because you're adding new things all the time.
Right.
But the packages don't usually change that often.
Right.
But on the other hand, if you add your files first and put the package.json in the end, what would that mean is your file changed. Now your package.json has to install the npm install again. The whole install of like 400 megabytes of npm modules you have to download all over again.
Gross.
Right. So basically doing this like simple like switcheroo, we can basically save even 5 to 8 minutes from your Docker build because you're not downloading any more of these things. It could do other things in terms of when you're doing like run commands to install a bunch of things. Instead of doing run this, run this, run this, run this, you can do run this and this and this and this and this. You can basically jam a bunch of commands with ands, or like on a bunch of Linux, you can actually pass multiple things to install at the same time as well. Doing this kind of things will make sure that you have less layers. The less layers you have, the smaller your image will end up being.
Okay. Right. So if you jam a bunch of runs into one command, though, then if anything in there changes, then it'll have to run that entire thing.
Yeah, but it still will be one layer, right? Another good practice would be to, if you know you need a particular version, you just like stick to that version. Like for example, instead of just saying install git, you can say git and set the version as well, what version of git you want. Because in that case, it will not, well, if it's a run of something, run will happen regardless. Every time you do it, run will happen. But if the layer doesn't change at all, it will not rebuild it, right? Okay, so you could do something similar. So remember, every single command you put in there becomes a new layer. And lower level changes should be all the way, like the change that happens more frequently, if you want to have it like much higher up in the order. Next is the copy on write. What does that mean? Copy on write is also an amazing system that makes Docker super useful. So you have, let's say, so copy on write means Docker system at like each level, and once it's written, becomes locked down as like a fixed layer. It doesn't change. It's immutable. Only the top container layer is mutable. That's access to you when you do, like when I exit into the particular container and do things. That's the container layer. We change that. Let's say you have a couple of files on the bottom layer here. Then you have a couple of files, and like this particular file then gets accessed here and changed here. That's when it's gonna get copied. If you change here, if you just use this layer here, like this particular file here, if you use that file but don't necessarily, if you use it right, like just like read it and do something with it, don't change it, it's not gonna get copied. It's gonna just directly use it from down here. Oh, it's fine. So, okay. Was I not showing this at all? That's sad.
Yeah, I'm not sure.
Okay. So again, like quickly recapping if I didn't show it. So basically, you have like layers from like 1 all the way up to n. So 1 all the way up to n. Oop. That disconnected. Hold on, let me reconnect back. Okay. So you have layers from 1 all the way up to n. And any changes on the bottom layer, if you change something here, all the layers up above it will have to be rebuilt. So you want to have the changing layers as higher up as possible, right? You don't want to like break the order of your application per se, but if it's possible to put it up, for example, doing the, again, back to the npm install thing, doing an npm install before you copy your code doesn't really break the application. So you can do things like that. So going back to copy on write, you can use anything from the bottom layers as you see fit. Unless you change that particular thing, it will not be copied. It will just read it. So copy on write also allows Docker to keep the Docker image size very small. Because again, it's only copying when it needs to copy, other than it's just like reading it. So these are the two things that allows Docker images to be extremely small. So with that, let's try to recreate this root reveal image using a Docker file instead of, try to recreate MyAlpine again using, how do I minimize this? Completely don't know. You know what? I'm going to just move it. There we go. So we're gonna try to create our the sample alpine, my alpine, using a Docker file now. So what do you think it needs to happen if I want to do this?
We need to make an actual Docker file.
Right. So we're gonna create a Docker file, and if you create the Docker file name in this way, Docker capital D, everything else lowercase, and when you do Docker file, if you use Docker build and dot, Docker will know to look for this particular file. You can actually name your Docker file anything and pass that file as a -f command to Docker build. But naming a Docker file this way is easier, first of all, because everybody expects it this way. So people can know where to look for when they're looking for a Docker file. This morning, I actually, for some reason, typed the F as capital. Go figure. So again, we remember what our base image was, remember, right? So our base image was, and the tag was stretch. And we ran a couple of commands. We ran apk update and apk add IP utils, right? And that's all we did. We didn't really have any like a command or entry point. You can actually create Docker images without entry point or commands. The image will just be like that. You only can like shell into it, otherwise it's not going to run. It's going to just start and stop right away. So that's all that particular Docker image has. So if I do a cat Docker file, so you're gonna see that there's just two commands. So I'm gonna do a Docker build -t, and I'm gonna call it my alpine, and I'm gonna give it a tag of, I don't know, Docker file. Again, the tag is basically just plain text. You can tag it anyhow you want. A lot of people will do Semver so that they have like a proper way of tracking how this thing changes. And I'm going to give a dot, basically saying look for this particular folder to find a Docker file if there is any. And it'll go ahead, whoa, damn, okay, I probably spelled it wrong. Okay, oh, alpine was not a stretch, Debian was stretch. That's on me. Alpine is just alpine. Okay, so I'm going to do this, and it's going to just go ahead and go do all these things. And it just downloaded that. So if I do a Docker images, you'll see that my alpine, both Docker files, the latest was the one I committed back. They're the same exact size. I can go through and find it, but like deal with exactly the same thing because I installed them exactly the same way. But this particular version built with the Docker file now, you can see that I can give you the Docker file, you can build it, or I can just put the file up on GitHub and you can download and build it. But the other way would be sending them this command.txt so that they can run the exact same commands as I see them here. So,
right. So, quick question.
Yes.
So you said so here you're doing APK update and APK add IP utils.
Mm-hmm.
So why can't we? I don't really understand why you can't just do two runs. Like, why is that?
Okay, yeah, let's just do that, right? So let's go back to Docker file again, and again, this is such a small image. It probably won't be much bigger of a difference, but now we're gonna see it right away. What the difference is. So right now, let's see. You see how many layers I have? I have 2 layers here, right? So if I do a Docker build with this, I'm gonna call it layered because there's layers. And if I do this, now you're gonna see there's 3 layers built onto this, and the size might not be different yet. It's not different because it's such a small thing, but again, every time your Docker image is building now, there is 3 layers. If I bring my tablet back again, which I should be able to. Oh God. Why? This is just shrinking, or it's not actually moving. What is this? Oh, there you go. Okay, so before we had 2 layers, now we have 3 layers, and it's just such a small change. You don't really see the change in files, but if you have a Docker file with 20 layers versus 40 layers with the same exact things, you'll definitely see the difference. in like size of.
So like what happens that it's making it so much bigger just because you're running a command in two separate steps?
Right. So basically, every time you run it, it creates a new layer. So the layer has to have a bunch of boundaries set, and those boundaries are something container runc and the Docker runtime is setting for each layer, because each layer has to be mutable. So they have to set certain flags and certain files that are not no longer be changed. And then on the next layer, they have to do certain things again. So each layer they do it. They might also have to, because they're changing certain things from the previous layer, they might also have to copy things from previous layer onto the next layer. That means the same file has two copies now.
Gotcha.
Yeah. So with that, once you actually, another thing you can actually take a look at. So first time we ran this particular build, it actually went ahead and downloaded the Alpine build. Every time after we built it, it just basically just said 4090 this particular, just pointing to this, because it already found Alpine in your system. If you actually push this image up to our registry, you're gonna see the same thing. If you have like a lower level, like a union files, the first two layers of the 3-layer file already available, it will not really push the thing either. Even in Docker Hub, the image registry does a union file system thing, where you push something, it only takes the things that it never seen before. All the things that already has copies of, it will just say, upload it and just point it. Oh, every time you need it, just point, download this and download the rest of the things from there. That way, you can actually even keep your registry size pretty small. If every single image was a unique thing, your registry would need a lot more space to store all these images.
Okay.
Yeah. So I think that basically, again, we didn't really dive too much deep into how you can add your user, all these custom things. I feel like those would require a little bit more time, and I don't want to go over 2 hours just talking about this. So next time we talk about Docker, we're gonna actually talk about how do you add a custom user, how do you then we'll take in one of your application, one of the example application from somewhere, build in a proper Docker image. We're gonna also learn about layered, a multi-step build. That's a new thing on Docker 18, although it's over a year old already, but it's still a new thing in terms of the Docker landscape. Docker is 6 years old, so 1 year old basically is ancient at this point. But again, a lot of people are still not using it properly, so we'd like to give them the information. So basically, next week we're going to learn how to add. So we just saw root is bad, but what is the right answer to that, right? So you're going to actually add a particular user group and a user and learn multi-step builds next time you use it. But next week we're doing, again, going back to AI stuff. If you could give a quick sneak peek or a little bit of taste.
So last time we obviously trained a model from scratch, but we only had one layer, barely even a layer, just an input and an output. So it's super easy to do. Well, not super easy, but very simple. Most neural networks have a bunch of hidden layers and stuff. So next time we're gonna actually try and hand train a model with hidden layers.
Okay.
And once we just do that, then you can scale to however big of a model you went. Yeah.
Sky's the limit, Nick. That's awesome. So with that, I think we're ready to stop for today. So thanks for joining once again. This video is going to be available on YouTube in a couple of days. And this is also part of a larger series on Docker. So you have a previous video already uploaded. You have a bunch of videos on how to install Docker for your particular OS. And we're going to keep adding more videos until we are proficient and masters in Docker. And then we can move on to Kubernetes and all other cloud native goodness as long as Nick here is interested to learn more.
Of course.
Yeah, so with that, thank you for joining once again. I've been Mofi, I have Nick with me, and see you next week.